Yeah, this last summer I actually interned at the Los Angeles Department of Water and Power, um, like the contracting company that works with them. It's called Inframark. So I collected some information about how water gets to the Burbank water and power station, and what happens to it. And I can share what I did during my internship as well. Um, so the Burbank Water and Power Facility, uh, the water undergoes several important processes. It goes through groundwater treatment. It comes from San Fernando Basin, sometimes contaminated with organic compounds and industrial pollutants. And water passes through series of treatment plants with carbon filtration and oxidation processes to remove them. This is like the first basic swab of the most dangerous pollutants. Then the second part is imported water, water from uh, from the Burbank um, water and power facility is treated at source either at Colorado River aqueduct or at the state water project facilities. It's blended with local groundwater, so that supply is more or less same. So if one is more dry and the other one is more resourceful, they kind of balance each other out. Then wastewater collection and treatment. Once water is used in households and businesses, it's collected again by the city's sewer system and directed back to the Burbank Water Reclamation Plant. So it has primary, secondary, and tertiary treatment. So yeah, it removes solids, then uses biological processes to break down organic materials, and further refines water, usually with chlorine and UV light. The best one is the reverse osmosis, where it does all of that step by step. And it also, Burbank does water reuse. Some of the treated wastewater is recycled and used for non-potable purposes like irrigation, industrial cooling, where you kind of can lower the standards of water so it's not drinkable, but it still could be used. For example, yeah, if it's industrial cooling or irrigation, it could serve for like long distances or in big bulks, and yeah, it still could have the same purpose. Um, yeah, and after the treatment, the purified water is released back to Los Angeles River, down to the downstream ecosystems. And what I did and what I kind of reflected on during my internship, I was at the data science center. It's called A&I. I more or less did data science on the uh, compounds that are being injected in the water. So how the sensors work is basically once you see that the levels of certain compounds are low, and then you press the button to inject more. Between those two processes, there is a lag of 10 minutes. And in order to prevent it, I proposed to use a machine learning algorithm, which could say, hey, those parameters have been lowering for quite some time. They correlate with each other in this or that way. Let's predict in advance to cut those 10 minutes in shorter, so that we can predict when we need to inject those compounds. Because if they're not being injected in a timely manner, if the time surpasses 15 minutes, then the whole batch of water needs to be rejected. And that costs the company obviously a lot of money and all the effort that has been put into the work. It goes to waste. So yeah, I used Python, TensorFlow, and AWS to propose a solution. It did not yet make it to the experimentation part, but I was told that I had a great proposal. So we'll see. Maybe next summer they're gonna invite me back to the internship. Um, uh, yeah, maybe I can also talk about the benefits and costs associated with the material. Um, I feel like from my internship, it was really interesting to know um, how how hard it is to take care of the water. We kind of take it for granted. We just open up um, the tabs in the kitchen, in the bathroom, and we just drink tap water or we filter it, and that's about it. But if you think about how much of supply chain has been broken after COVID, how much um, new diseases or new compounds in water need to be efficiently treated, uh, and how much, for example, if there was a surplus of water from Arizona, let's say right now it's overheating and there is no water from there, let's say, hypothetical situation. So all those factors need to be predicted in real time, and it has to be reliable. So there always has to be a reserve of water needed um, to be used for the whole city of Los Angeles, let's say, and it's huge. And yeah, a lot of people are working at the Los Angeles Department of Water and Power. I live over here in El Segundo. I can see the water treatment plant, the Burbank plant. That's also very helpful, and a bunch of more. And from basic technicians to operators and machine learning scientists, even. um, it was crazy for me, in a good way, to learn how much thought goes into it, how high the standards are. Um, yeah, I also feel like some people like to complain that maybe like the water is not perfect, but even the quality that it is right now, the work that goes into thinking about the pipes, uh, thinking about where it comes from, how it gets treated, how it gets stored, it's a ton. Yeah.